Okay, let's dive right into this. We're going to talk about one of the most important topics in system design, performance. And more importantly, we're going to see why that one shiny number you probably track on your dashboard, yeah, the one you put in all your reports, might be telling you a pretty big lie about your user's experience. I mean, it's the first question we always ask, isn't it? Whether you're building something new or just trying to improve what you have, it all comes down to speed. How fast is it? It sounds like such a simple question, one that should have a simple answer. But here's the thing. That simple answer, that single number we all love to report, it's basically a mirage. It smooths everything over, hiding all those frustratingly slow moments that make people want to leave your app and never come back. So to really get why that number is so misleading, we've got to clear something up first. It's a point of confusion I see all the time, even with really experienced engineers. And that's the difference between how fast something is and how much it can handle. First up, let's talk about latency. This is just pure raw speed. You know, from the second a user clicks that buy button to the moment they see the confirmation page pop up, that's latency. It's all about the time it takes for one single action to happen, and it's what a user feels as fast or slow. So if latency is speed, then throughput, that's all about volume. Think of it like this. Latency is like asking, how fast can one Ferrari go on a totally empty road? Throughput is asking, how many cars, Ferraris, buses, you name it, can this whole highway system handle during rush hour? See, you can have the fastest car in the world, but if that highway is completely jammed, your personal experience is going to be awful. They're just two fundamentally different problems to solve. And that difference right there brings us to the heart of the issue, the problem with averages. This is where that misleading number on your dashboard comes from, and it's precisely where your user's pain gets completely hidden from view. So you're looking at your monitor and you see this, an average response time of 60 milliseconds. Looks amazing, right? We're fast. High fives all around. But I'm telling you, that number is a total illusion. You know, there's a great line in the book, Designing Data-Intensive Applications, that just nails this. It says we have to think of response time not as one single number, but as a distribution of values. It's a whole range of different experiences, and the average just flattens all of that beautiful, messy nuance into one totally unhelpful number. Okay, so this is what was really going on behind that nice, clean 60 millisecond average. Yeah, sure, most requests are super fast, but look over there at the tail end of the chart. You've got some users waiting 400, even 900 milliseconds. That is almost a full second of just waiting, and in web time, that's an eternity. These aren't just outliers, these are real, frustrated people, and using an average just completely erases their experience from the record. Okay, so if we can't trust the average to tell us what's really happening, then what should we be using instead? How do we actually see the whole, unvarnished truth? Well, the answer is something called percentiles. This is how we make the shift from just measuring some abstract system to actually measuring the lived, real-world experience of our users. So what is a percentile? It's basically a line in the sand. For example, if you are 95th percentile, what we call P95, response time is 200 milliseconds, it means 95% of your user requests were faster than that, but it also means the other 5% were slower. And the P99, that looks at your absolute slowest 1%. See, we're not hiding the outliers anymore. We are putting a giant magnifying glass right on top of them. We are specifically measuring the worst experiences. And why does focusing on the worst experiences matter so much? Because, and this is a quote from Fundamentals of Software Architecture, it's that long tail, those slow requests at the 99th percentile that will absolutely kill the performance and the perception of your system. And think about it. Who are the users having these slow experiences? They might actually be your most valuable customers, the ones with tons of data in their accounts, or the ones trying to make a huge purchase. This is why companies like Amazon and Google are absolutely obsessed with these tail latencies. They optimize for P99.9 because they know that a bad experience for even a tiny fraction of a percent of users can have a massive impact on the business. All right, let's bring this all together with the final and maybe most counterintuitive piece of the puzzle. How does this all play out when you actually try to scale your system? This is where a common solution to one problem can secretly create a much, much bigger one. So what's the standard playbook for handling more traffic, for increasing your throughput? Horizontal scaling. You just add more servers. Easy enough, right? And lets your highway handle way more cars. But this very solution can introduce a hidden and pretty dangerous new latency problem. You see, in a modern distributed system, a single request from a user doesn't just hit one server. Oh no. It kicks off this whole chain reaction. The request hits a load balancer, which then calls an authentication service, which then has to call a user profile service, which then calls an order service. All of this has to happen before a final response can even be put together and sent back. And this is where the cost just becomes brutally obvious. Take a look at these numbers. Every single one of those internal calls is a network hop, and every single hop adds latency. A simple round trip, even inside the same data center, can take 500 milliseconds. Now that sounds tiny, right? Half a millisecond? But remember that chain reaction we just talked about? If a single user click needs, say, 10 of these internal calls to happen, you've just added 5 milliseconds to your best case scenario. And if just one of those calls is slow, it drags the entire request down with it, creating exactly the kind of painful tail latency we've been trying to avoid. So here's the big paradox we've been building up to. Your effort to increase throughput by adding more servers can actually make the latency for individual users worse. By creating these complex chains of internal requests, you've massively increased the probability that something, somewhere, will be slow, and that poisons your tail latencies. You solved for volume, but you ended up sacrificing speed right where it matters most. Which really leaves us with this final thought. When you look at your performance metrics, what are you seeing? Are you celebrating an average that hides the truth, or are you digging into the percentiles that tell you the real story? Are you building your system for some imaginary average user, or are you building a resilient system that works for every user?